So we're going back to nuts and bolts, and the 2024 Earth Building Standards, update to the 2020 version. I'm going to start, Graham's going to carry on, but I want to acknowledge Richard Walker, who is busily working on it probably as we speak. And so that's me. I worked for 30-something years at the university. I'm an honorary academic, which means that I'm still doing some stuff but not paid anymore. And Richard's not here, but there's, out of our committee, there's Tace, Peter, Alan and Min are here, and then the others that are not here today. And Martin is here, who's done a whole lot of drawings. Really need to acknowledge him as well. The very quick history is that we started on the update to the 1998 standards in 2010 with a lot of effort, mainly at Graham's house. And then there was a hiccup in 2016, no money. You guys raised a lot of money, we restarted. 2020, we published new standards and they were not accepted by the building code. So we're going through a revision, lots more effort, and that's where we are today. It's nearly there, but still going. What has happened in the 2020 standards is we've got low density earth is one of the core things. Because we need more insulation, then going from the normal density to a lower density is really helpful. But we also have straw bale, light earth, like we saw today in the tour, and internal adobe veneers. So they've been added in. And I'm going to, the arrows moved, but we're going to look a little bit more at the low density earth later. So some of the changes that have happened since 2020 are lots of revised drawings, which Martin has done for us, new span tables and bond beams and lintels, moisture management, how you need to look after that within a building, a maintenance schedule that you need to say what needs to be redone at different times to comply with the building code, and no change, significant change to the appendices, no change at all, I think, to the straw bale. So that's for that's the main standard that lots of people are using, 4299. For 4298, the materials and construction standard, which gives you we've got sections on repair of walls, which goes alongside with this maintenance schedule sort of stuff, so that you need to know, and it's prescribed how repairs have to happen, and there's a little bit more on the flexural bond test. When we come to the engineering design, we have limited the height largely because of earthquake concerns. So it's now 6 meters is the maximum height on any part of a wall, and then for 2 stories, only the lowest story is earth up to a maximum of 4 meters. And unreinforced earth is not permitted for new construction, but the instructions for it are kept in an appendix. So that's any corrections to that from, no?
But when you say the instructions are kept in the appendix, is that for when a historic building
Yep.
needs to be analysed and repaired?
Yep.
Thank you.
So I'm now going to focus on one of the questions that the MB and the BSP asked us. We want evidence that your buildings proposed from this standard will be to work in 50 years' time. That's one of the big questions, and I'm going to tell you some of the ways that I've answered this question, and I'm wanting you to give me feedback on better ways to answer the question. And particularly, we're talking about low density earth. That's at the bottom there, you've got your standard adobe, the top one where there's more wood fibre, wood chip, straw, vegetable fibres, much lighter weight, lower density block, and that's the question that we've got the most, have to be convincing them about. So the challenge is, how do we say that these will last for 50 years, they'll resist extreme events, and this will later come to straw bale as well. So just take note of this. When we come to make the straw bale normative, we'll be getting the same questions. So at the moment, this is a question we're getting for low density earth. It will come later. And so my first argument is about the long-term history, where we've got hundreds of years of international knowledge, a little bit of long-term New Zealand knowledge, materials within an earth matrix, how they work, and then, of course, we need to be convincing them that we're using examples that are similar to what is in the New Zealand climate. Wind-driven rain and temperate climate, and we've got many years of Europe, but it freezes every winter, and so that's not great for the insects and the mold, and so we need to have comparable climate to be giving this sort of feedback. So in New Zealand, we've got broad green, 128 years old, cob, had a few years where it wasn't so well maintained and there was a bit of moisture coming in, but it's repaired and livable. And so some lessons for us. Exactly how much fibre decay, probably we need a little bit more information on that and some of the details of that, but that's one example. We have examples of exposed cob, where they've been in moderate levels of exposure around the country, probably built in the 1890s, but it would be really good if we had real records and no information. And how long has it been exposed? Probably 50 years, but it's only partly degraded. It's still there after all that time. And after the 2016 earthquake, magnitude 7.8, where there were a number of old historic earth buildings got damaged, we found this building, and it had been exposed for many years, but what you can see is the fibres on the wood are clearly intact. So probably they've been embedded for 100 years. The walls have been degrading around them, and when they pulled apart in the earthquake, you can see these fine fibres exposed. So those fibres, those little timber fibres, are still existent after all of that time embedded in the earth. So, yes, we do have buildings lasted more than 50 years, and we do have wood fibres that have lasted within that matrix. Overseas, of course, 16th century, where we've got earth matrix embedded in between wood, and where probably similar humidity to us, where it's been more than 400 years. What we don't have is the maintenance history, but we do know that that's been there a hang of a long time, even longer in Germany. And you can find, so we're really keen, if anybody knows where there's anything that we can find that actually tracks some of these things, and we can just nail that evidence down a little bit tighter. And Wattle and Daub, those on the tour were privileged to see some of this today, where you have these vertical wood staves and then woven wattles, and then the clay loam pushed into it, and then some surface roughness before the plaster goes onto it. And that's some historical stuff, probably a couple of 100 years old, but you can see that wood still intact inside the wall. This is UK.
Is that hurricane mesh netting over the top?
It's scratched.
The black lines are scratching.
They're scratched, yeah. And then this is another form, but again, intact within that matrix. No degradation. And so really good long-term durability. So from these, we say that's good evidence within a heavy earth matrix that we're confident of this material. So going back, our challenge with low density earth, and we're going to also look at the medium-term stuff that we know about, the extreme things that we know about, some of the biological science, and some of the protections. And so let's go through and look at some of these. And again, my answers I'm giving you, better answers I welcome, and if there's things that we haven't answered that when this goes to public comment we might get, please tell us so that we can be prepared ahead of time. This is a 15-year-old, the earliest, I think, light earth building in New Zealand. You can see the lightness of the earth brick because it's floating in the bath. Only reports of some loss of surface fines after 15 years, probably due to abrasion. This is, I think, your place, Graham. At the time it was built, a light earth plastered with earth soon after construction, small overhang, would not comply with the standards, but after 12 years, no visible degradation. This is a house which I think a number of you probably visited last year in Takaka, Golden Bay, and it's here, 130 metres above sea level. Very good overhangs, a good line plaster, and last year we had these massive storms, 750 millimetres of rain, 2.5 feet of rain in August, and on an exposed site, the walls got a bit wetted, but no degradation and no damage from that extreme event. And then I did some testing in Nelson, and Verena built some walls for us in 2017, pulled them down, rebuilt them in 2019. They are walls that we were using for structural tests, but they were just left up and exposed. So there's only thing that's on top of there is the bond beam. There's no protection at all. And so after probably 500 millimetres of rain, we don't know the exact number, what you have is a small amount of erosion. This little point here is because it was a broken brick from the earlier tests when it's put back together. But that's an exposed wall, 5 years, and a major storm. And that's the sort of level of degradation. So I think that that is a very convincing sort of evidence that they've survived knowingly for 15 years, extreme events, and so we're confident about long term. And then going on to the science, where you know about the accelerated erosion test, and this is very severe, but we know what the results mean, and when you go to low density earth, it works fine and in fact works better than heavy density earth materials. That's supposed to be a floor that's rock where it sits on a beam. We actually saw a much better example of that today, where we looked at a school where we saw some capping that had been left and it was rotting. But we do expect fungal decay if something's kept moist and warm over a period of time. But when you build an earth wall, once it dries out, the moisture content within the wall is around 6%. When we look at fungus, it grows at a moisture content in timber at about 18%. It's something similar in straw. So that we know that when you have a moisture content inside the wall of around 6%, then you're not going to get microbial growth. And so the other thing is that the clay absorbs moisture from those materials. And when you're building, when you look at these light earth, you're coating it with clay, and that clay is giving you a protection around your straw, because it's absorbing that moisture so that it reduces the microbial attack. Fortunately, we don't have termites, but white ants and borers are not a problem. But where we do have insects and mason bees and vermin, then your plaster coating is going to be what protects you. I have got a little picture down here of these termite tracks where they build themselves a little tunnel, and then in Australia you have to be very careful with a timber house to make sure you stop that tunnel getting into where your wood is. But we need to be being careful with our plasters, and one of the things that we have got in the new standards is a bit more rigorous definition of how the plasters need to be applied. And the MB are particularly worried, can we look at what you've said in the standard, and the inspector can go and look at it and say, yes, it complies. And so that's been one of the things that we've dealt with. And so my argument is, once it's dry, very little likelihood of decay. I did notice when we looked at the straw in the earth, light earth, you will end up with a little bit of fungal where it's still damp. But when it's dry, won't be any more growth. And so good plasters will prevent insects and vermin. And the thing that we need to convince the Standards Authority is it will last at least 15 years before it needs any maintenance. So that's the standard we need to meet. And so that's my story. And really very keen to hear from people with experience related to durability, people that have got questions about these things. If there's anything that we need to make sure that we cover, so when this goes for public comment, we know how to respond when anything comes back to us. So that was the things that I just wanted to say, and probably should go move on to Graham before we take any questions. So maybe we'll just leave that one for a second. Yeah. Oh, yeah, go to the next one. That one? Okay.
Yeah, thanks everyone. I'd like to thank Athena particularly for that wonderful talk. While she's having fun, we've been doing some horrible stuff. And I'm starting to feel a bit resentful about it too. My report is in two parts. One part's official and one part's unofficial. And Hugh's already talked about the process we've gone through. We finished the 2020 standards. The regulators refused to take part in that process. And so when we'd finished the standards, they were published. After a bit of fuss and bother, they looked at them and they said, oh no, we don't like those. Or we don't understand that bit. Or we don't know anything about earth building at all, but what does that mean? I thought, oh, goodness. So it's very, very frustrating, and it took a while to get the old committee officially reformed. And it had the same people on it as the last committee, pretty much. We had to have a couple of new people turn up because a building inspector from Tasman, who was the Territorial Authorities representative, had moved on to work for MB, so he couldn't be on the committee apparently because that was a conflict of interest, even though he was the only person within MB who knew anything about the topic. And we had to get a new Boynes building officials and inspector official there. So when MB looked at this thing, I mean, Hugh already said they came up with a list of 88 difficulties. They had, some of them were trivial, some of them were a bit more substantial. And we also found just a few little typos and things which could be corrected. We also, you know, as time goes by, you learn a little bit more about one or two subjects. There was a little bit of technical content we could tweak. So we ended up with about 100 topics that we wanted to change, 100 changes we needed to address. I reckon if the MB officials and us had sat down for 2 or 3 days, we could have sorted the lot. If everyone was being cooperative and collaborative, I think that would have done it. It's not what happened. But anyway, after endless Zoom meetings, there's one. I don't know if I should identify the players or not. This guy's from Sanders, New Zealand, St. Mason, Auckland, Richard August, Virgin. Here's one about people I won't name, who was here's this was replacement. That guy, he was so topic, who was dead. Christine was there, he's an engineer with me, and there's me scowling in the corner. But anyway, what I can say is, despite a few hiccups, I mean, all the amended content has now been agreed between the committee and BSP, with only a couple of items still to be completed. And so we're now extremely close to the standards being prepared for what the next step needs to be. They have to go through a statutory public comments stage. And we're still hoping that this may be possible to occur before the end of this year. So we have made progress slowly. Any public comments that are made are strictly limited only to the amendments that we're making. So the bulk of the standards as they are, where we've had to change something or we've wanted to change something, then that will be up for comment. And once those comments are considered by the committee, the amendments can be made, or further amendments made if necessary, and then their standards get adopted officially by an outfit called the Standards Board, and then they become official amendments to the standards. By that time, BSP, the MB, Building Systems Performance is a branch within the MB. They've got a few procedural procedures of their own they have to go through. They have to do risk assessment. They have to make sure that what they've looked at many years and advised on actually meet the conditions of the New Zealand Building Code. And they also have to go through another public consultation process themselves before these standards can be cited as acceptable solutions. And that's what we've been aiming for all the way through. So, you know, although it's been frustratingly slow and difficult, you know, we have actually got through the work. And, you know, I take this opportunity to thank the members of the committee, along with EBANZ and those who have helped from outside the official committee, who have contributed to the invaluable content and offered ongoing support. So that's sort of where we're at.